This lesson is about complex numbers, and it's just kind of a standalone lesson depending on your background in mathematics. This is often covered in Algebra 2, but occasionally some teachers will miss it, especially if there is some sort of a schedule constraint, or if you happen to be taking, your algebra class when everybody went home for the COVID isolation time. Sometimes this did not get covered. So for some of you, it may be review, and for some, it may be new. In the real number system, whenever we run across the square root of a negative number, all that we've said in the past is you can't take the square root of a negative. Can't take the square root of a negative, or the square root of a negative isn't real. But in mathematics, I kind of visualize that mathematicians don't like it when suddenly a pattern stops working. So while we have said before that you can't take the square root of a negative number, Bob the Builder, mathematician, is going to step in and say, yes, you can. And we use imaginary numbers. Now, I realize some of you are probably saying imaginary numbers, this is just crazy. They're making stuff up. Well, it's not me making it up, but it is something that does have some applications that are a lot more complex. And it's, again, it's not something we're going to use a lot, but you just kind of have to decide that there was some sort of a superpower that just said, I'm going to accomplish this, and we're going to make the pattern work. Okay? How is it that it works? Well, there's a definition, and I've got down there highlighted in yellow. Since it's a definition, you just can't argue with it. Dictionaries do not care. You can moan and whine, but you're not allowed to look up a word and say, I'm just not going to accept that this is what it means. So the two definitions you simply need to memorize. Make a note of it. I is equal to the square root of -1, and I squared is equal to -1, because the definition of a square root in and of itself is that when you square something, you'll get that thing. And so therefore, if I is the square root of -1, then I squared is -1. And everything else we do in this lesson will be based upon this definition. So you just have to maybe pretend you read it off the lid of the box, and that's the rule, and that's how we're going to play. So if we have a negative number underneath the square root, then we're really going to be able to simplify it by saying, hey, I know that this negative, that negative number, I don't care what it is, we'll call it -a, that's fine. That -a under there means that this is the square root of -1 times a, which is the square root of -1 times the square root of a. And this is where we can apply and say, oh, well, by definition, the square root of -1 is I. And then I'll just take the square root of a, whatever that is. So a lot of times we just kind of shortcut and say we're going to take the I out. So this one, what will happen is, because of this negative, I can simply take an I out, because that's I could follow it just like I did up there, but this is going to be the square root of -1 times the square root of 49. The square root of -1, though, is I, and then the square root of 49 is 7. So first of all, I take the I out, and we get I root 49, but then the square root of 49 is 7. Now, by convention, which means it's not real critical, but it's how we typically do it, you just need to write it so that that I does not look like it's underneath your square root. So up here, when I did this at this upper area, I wrote the I in front of it so that it wouldn't possibly look like it was underneath, because if I were to stick it underneath there, you might say, is it under the square root or is it not? So if we have a square root, we normally, by convention, will write the I in front. And if we don't have a square root, we will write it behind, kind of like a variable. So now looking at this next one, these two negatives do not cancel each other out. You cannot look at it like that at all. Because of the negative that's underneath the square root, I'm going to take an I to the front. Now my term is still negative, but then I need the square root of 121, and that's 11. So I still have a negative. I have an 11 for the square root of 121, and I have an I for the square root of the -1 that I know is multiplied to 121. Here, I'm going to stick an I in front. Now the square root of 3 doesn't simplify, so I can simply say that is I root 3. Now when you're typing something like this into your homework, you can put the I behind it, but you've got to make sure you hit that right arrow key to get you out from underneath the square root first. Make sure your I is not still under the square root. Now this one is a little bit different just because the square root of 32 is different, and there's more than one way to think of these. But first of all, I'm just going to say, well, because it's negative, I know I have an I. And then one way to think of it, I'm just going to break it down and say that 32 is the square root of 16 times 2. And then the square root of 16 is 4. So for the 16, I have a 4. The square root of 2 does not simplify. So 4i square root of 2 is that one. Which means we often just say, take the I out. Take the I out. So change the radical, and when you see that negative, you want to just say, okay, very first thing I'm going to do is I am going to take the I out and change it to I root A. If we have some math to do, inside to inside and outside to outside, first of all, take the I out, and then multiply anything that's in front to anything that's in front, and anything that's underneath to anything that's underneath. That's what that means, underneath your square root, and then we can simplify further. But take the I out first. It's not very often you'd have a really large number, but you might look at a number sometime and not know, hey, when she did the square root of 32, she just said it was 16 times 2, and I knew the square root of 16. But you don't always know. So whether or not you have a large number, like this 1,800, or you simply have a number that you don't know what divides into it, there is a way to find this out. What we can do is factor it. Now you can use a factor tree like you might have used in grade school. I use what is kind of an upside down division, or I call like a factor ladder, and I'll put my division symbol upside down and simply constantly look for not just what divides into it, but what is the smallest prime that divides into it. Now just as a note down at the bottom, prime numbers, because we're not going to have to use lots of them, but we have 3, 5, 7, 11, 13, 17, and of course the list goes on. But you just want to divide by the smallest prime possible. Okay? So, oh, and I left off a 2 with the most obvious one. So 2, 3, 5, 7, 11, and you're not getting any more than that. So if I divide this by 2, and I'm writing the answer underneath. Now, what is the advantage to doing this upside down division as to regular division is that you normally have more room going down on your paper because we start at the top of our paper. And that's the only thing. So I'm just doing division. I only want to divide by things that divide into it. I can still divide this by 2, and that'll be 450. Divide that by 2, and I get 225. Now I can no longer divide by 2, so I want to move to my next number on my prime list, which might be 3. And if 3 didn't go, I would just move on to 5, but 3 will go into that. 3 will go into 22 7 times, and then it'll go into the 15 because I can carry my remainder back. It'll go into 15 5 times. Now 3 will go into 75 25 times. Now 2 won't go anymore, 3 won't go anymore, so I move to the next number and I get a 5. 5 goes in there 5 times, and then 5 goes in there 1. And when you get to 1, you're done. So what happens is here on the left, you have all of the factors lined up. And then you can simply look for pairs. There's a pair of 2s. Here's a pair of 3s and a pair of 5s. Now this 2 does not have a pair. I'm just going to draw an arrow the other way. And what happens is that I can take these that I've said I have a pair of and multiply them back together. So 2 times 3 is 6. 6 times 5 is 30. And then that 2 that was all by itself is just going to stay under the root, so that the square root of 1,800 is 30 root 2. Now, you're not likely to have numbers that big, but that sort of a thing would have worked even on a different example. So just to show you, when I did 32, and I said it was 4 root 2, watch how that would have worked with this. You can divide by 2, 16. Divide by 2, I get 8. Divide by 2, I have 4. Divide by 2, I get 2. Divide by 2, I get 1. When you get to 1, you're done. There's a pair of 2's. Here's a pair of 2's. And then this 2, I'm going to draw the arrow the other direction. So these that I put in front, 2 times 2 is 4. And this 2 that's left over stays inside, and it's 4 root 2. So I did it another way. This is a method that will work if you get stuck on trying to simplify those. If we're going to do multiplication and division, don't forget it said the very first thing you have to do is take the I out. So I'm going to put an I in front, put an I in front, then do the outside to outside, inside to inside. I times I is I squared, and 4 times 16 is 64. Okay, well, I squared by definition is -1, and the square root of 64 is 8, so this one is -8. Take the I out first. Then multiply in front. I times I is I squared. And then inside, 5 times 11 is 55. Now, the square root of 55 doesn't simplify because that's just 5 times 11. But I squared is -1. So I have negative, for that -1, root 55. Take the I out. I squared, which of course will make it a -1 times something. And then 3 times 12 is 36. The square root of 36 is 6, and the I squared makes it negative. All right, so I have an I on the outside. Inside, I have 13 times 2, which is 26. That does not simplify at all. So that actually is the answer, I root 26. Take the I out first. Since we took an I out on both of them, they do cancel. Then we can do inside to inside, the 72 divided by 8. 72 over 8 is 9, and then the square root of 9 is 3. Take my I out. 48 divided by 3, because they're both underneath, is 16. And the square root of 16 is 4. Take the I out, then do outside to outside, inside to inside. This is just one of these informational slides. If you put a number that has an I with it, and you add or subtract it to a real number, then you end up with a complex number. And when you have complex numbers, you can add or subtract or multiply them. We can divide them, but we actually do that by a type of multiplication. When we add, you add the real to the real part, the imaginary to the imaginary. When you subtract real to real, imaginary to imaginary. And when you multiply, you use the FOIL method, and then you simplify because we know I squared is equal to -1. So just to give your brain just a little bit of break here, you know, if you have your real and then you put your imaginary with it, that's called a complex number. So instead of saying it's complicated, it's complex. These are all complex numbers with some math done to them, so let's just do this. Now we're going to do real to real, imaginary to imaginary when we add and subtract. So real to real, -3 plus 4 is 1. Imaginary to imaginary, 2 plus 7i is 9i. So very much like when we've done this with variables, even though I is not considered a variable. 7, now don't forget this is a minus in here, so 7 minus 3 is 4, and 10i minus 5i is 5i. Now, a lot of times, I'm going to say up here, a lot of times people are better off if they just rewrite it by distributing the negative, because it's a common mistake for people to forget how that negative is taken through to all the other things, but whichever works for you. So on pluses, it's different. Real to real, you can do that with all three of them. So 5 minus 3 is 2, plus 6 is 8, minus 1i or negative I, plus 3i is 2i. 2i minus 4i is negative 2i. Again, because it's got the minus in between, a lot of times you're better off to distribute, because then you can see that that minus the negative makes it a plus, and minus the negative is going to make that a plus. You don't have to do that if you can keep that straight, but -1 plus 1 on our real terms are going to go away, and then 12i plus I is 13i. So that's add and subtract. So now let's multiply. Now here I don't need to FOIL on the first one because I just have the one term there. But we are going to distribute, okay? So that gives me, you know, when you multiply, anything can multiply. Okay, they do not have to be like terms at all. So this one is 24i plus 18i squared. Now we know I squared is -1. And then -1 times 18 will simply make that minus 18. However, in complex numbers, if you write it in standard form, you write the real part first. So even though this ended up here at the end for my final answer, I'm going to put -18 plus 24i. First, it's like repeated distribution. Distribute the 6 through that second parentheses, and that'll do the first and the outside. So I get 12, and then plus 24i. And now I'm distributing the -4i to get my inside and last, so that's going to be -8i minus 16i squared. Okay, now we're going to simplify. It's easiest just to get in the habit as soon as you write down I squared, because we know that's a -1 and we know it's going to change the positive or negative in front. Just cancel out the I squared, and change the sign in front of that term. So then we can see that 12 is a real number, and now we have a 16 that's a real number to add to it. So as we simplify this, 12 plus 16 is 28. And then on the imaginary parts, I have 24i minus 8i, so that gives me 16i. All right, let's do this next one. First, outside, inside, last. Because I see this I squared, I cancel it out and immediately change that sign in front. So now my real parts are that 9 minus 8, that's 1. And then the imaginary parts is 12i plus 6i, which gives me 18i. So multiplication, and then simplify the I squared part. This is going to help you out on some homework. The I values, even if you start putting really big exponents with them, they cycle in this order through these answers: I, -1, -I, and 1. And you can actually figure out what the answer is very quickly by just doing a little bit of division. For example, since there are 4 answers here, if I did, how many groups of 4 are in 7? Well, just one group, but it's not really the groups I'm interested in. It's what is the remainder. So just focusing in on this one, okay, where it says I to the 7th. If you wanted to get that answer real quickly, what you can do is just think, well, if I divided it by 4, what would my remainder be? So if you do 7, because that's the power, and you divide it by 4, because there are 4 different answers to cycle through, it goes in there one time, no big deal. But the important thing is the remainder is 3, which tells me it's going to be the 3rd answer. So if you look at these answers in order, that gives me a -I. And if you look at all the work they did, they ended up with a -I. So you can kind of hop skip over a lot of that work by just looking at the answer. So if your remainder is 1, you get the first answer, which is I. If the remainder is 2, you get your second answer, -1. Remainder 3, we've already said, it gives me that -I. But you're never going to get remainder 4 because you are actually dividing by 4. So what happens is that if you have a remainder of 0, then you get that last answer because you ended up there. So you can use that approach to find out some really high powers of I, and they may have you do that some. So let's look at these. Now again, I've written this down at the bottom. We're either going to get I, -1, -I, or 1. So what we want to do to quickly do that is figure out what is the remainder if we divide by 4. So 37 divided by 4. Well, 9 times 4 is 36. But since I needed 37, that gives me a remainder of 1. So I to the 37th is going to simplify to that very first possible answer in that lineup, which is I. All right, well, what about 75? 75 divided by 4. 4 will go into the 7 one time. I kind of carry my remainders, so it goes in there one time with 3 left over, and 4 will go into 35 8 times. That'd be 32 with 3 left over. So it's got a remainder of 3. So this one simplifies to that 3rd option, which is -I. I mean, because nobody wants to write down I 75 times and then start looking at pairs of them, which gives you -1, and figure out what's going on. We just want to cycle through very quickly. So 58 divided by 4. Well, 4 will go into 5 one time with 1 left over. 4 will go into 18 4 times, that's 16. And then there's 2 left over. So my answer is that second one in the lineup, which is -1. And this one will go quickly. 80 divided by 4 is 20. Of course, the important thing there that we normally wouldn't write down is that it has a remainder of 0. If it's got a remainder of 0, that took us to the last thing in the lineup, and the answer is 1. So what we haven't talked about is how to divide with complex numbers. And I did mention earlier, we do divide with them, but we use a different approach of multiplication. So in order to use these instructions, the instructions to divide a complex number is multiply both the numerator and the denominator by the complex conjugate of the denominator. Well, I often have students tell me they think they could do something if they knew what it wanted them to do. So this is our key word here that we just got to get figured out, complex conjugate. So the complex conjugate has the identical real part, but the opposite imaginary part. So the quick fix there is, if you notice the way this is written, a plus bi, and the next one says a minus bi. You're just going to change the middle sign, leave the first one alone, and then we're going to change the middle sign, and that's our complex conjugate. Now, we only focus on the denominator. We need to use the complex conjugate of the denominator. So keep your eyes focused on the denominator as we go through this. So here, this is 4 plus 2i divided by 1 plus 3i. So if we're going to work this one out, the complex conjugate of the denominator is 1 minus 3i. But even though I determine my complex conjugate by looking at the denominator, you have to multiply both the numerator and the denominator by that same thing. Now we can see then that this is really a weird looking 1 because anything over itself is 1, but that's what makes it legal to do. You don't have to put the parentheses up, but what this essentially means then is that I have binomials that I need to multiply, so I can use FOIL. Okay, so on the top, using FOIL, first, outside, inside, last. Because I got that I squared, I'm going to line out I squared and change the sign. I am going to go back and do this to the bottom, but I just want to keep our focus on the top right now. Let's go ahead and simplify this. So now 4 plus 6 is 10, and then negative 12i plus 2i would be minus 10i. Okay, now let's look and see what happens to the bottom. This is really where the magic is. When you multiply two complex conjugates, you end up with the real number, even though we started out with some imaginaries. However, we can just crank it out by FOIL. So first, outside, inside, last. I got an I squared, so I'm going to line it out and change that sign. So the real part, 1 plus 9, is 10. And the imaginary parts, voila, they cancel out. And that happens every single time. So now, since both of those top parts are over 10, they're each over 10, so I can divide 10 into all three of those, and you just end up with 1 minus I. And that's the answer. Constantly, you've just got to do that complex conjugate. Now, the complex conjugate, when you only have the one term here, is not quite as obvious, but just remember that this is a 1, this is not a 1, this is a 0 plus I, which means the complex conjugate is 0 minus I. And again, if it's 0 minus I, then why did we write down the 0 anyway? Just know that if that is an I, it's a positive I, which means the conjugate of it is a negative I. Okay, you don't even have to write down that plus there, which means we want to multiply both the numerator and the denominator by negative I. On the top now, since I don't have two terms on that second one, I can just distribute negative I. So I get negative 5i plus 4i squared, but then I squared changes that sign. On the bottom, that becomes negative I squared, but I squared is negative 1, and a negative times a negative 1 is 1. Since this is over 1, I no longer need to write the denominator down, so I just want to write the real part, negative 4, and then the imaginary part. At any rate, whether or not you have a single term or you have the binomial, once you multiply something by its complex conjugate, which only changes that middle sign, you will end up with the real number. One of the challenges in this homework assignment comes at the very end with the GeoGebra problem. And the primary difficulty, I think, is understanding the instructions and what you need to do to complete the problem. So I've copied those instructions here. Write two complex numbers. Now, z sub 1 equals a plus bi just means this is the first number. Z sub 2 equals c plus di. Okay, this is the second number. So write two complex numbers that don't include a 0 or a 1. That's what it means when it says with A, B, C, and D not equal to 0 or 1. So don't pick a 0, don't pick a 1. But you have to have two complex numbers that have a product of, and that part will be given to you in the problem, but it's not the same for everybody. It could be a whole number like 12, or it could be a complex number. So they will give you what the product needs to be. The process you need to go through to get your answer, you can see over here in the bottom left, you just pick your first number. And remember, don't pick a 0 or 1. You're going to pick a number in A plus BI form. Now I am going to pick, and it doesn't have to be like this at all. I am choosing to pick 2 plus 3i because I can't pick a 0 and I can't pick a 1, but I can pick a 2, I can pick a 3. I could pick 117 over 23, but who wants to? Don't pick something that makes your work too hard. Now, after you pick your first number, notice it says then the given product, whatever they give you in your homework, over the number you pick. When you simplify it, you will get your second number. Now, here's how this works without complex numbers. And I'm just going to put this over here on the left. It's like if your product had to be 20, and you had to pick two real numbers. If you pick the first number, like a 2, and then you put 20 over that number, well, you can see here that 20 over 2 is 10. So I end up with the second number, so that 2 times 10 is 20. If I were to pick 5, I could do 20 over 5, and that would give me 4, and again, 5 times 4 is 20. This same concept will work with the complex numbers. So they will have given you a product. So I'm going to fill in here a product that's possible to be given. Like, suppose they say the product has to be 5 minus 3, I'm having trouble making my pen work, but 3i. Then what you want to do is take the product that they have given you, 5 minus 3i, and we'll put it over the number we picked. I picked 2 plus 3i, and we'll simplify. And this is where that last bit of work that we were just practicing comes in, because to simplify this complex fraction, we need to multiply both the numerator and the denominator by the conjugate of the denominator. So my conjugate is 2 minus 3i. Just change that middle sign. Now, as I do this work, on the numerator, I can FOIL. First, outside, inside, last, or repeated distribution. So 5 times 2, 5 times negative 3i, negative 3i times 2, and negative 3i times negative 3i. But since that particular product has this I squared in it, I squared is going to change that sign back to a negative there. Now we're going to simplify that, but I'm going to come back and do that on the next line. Right now we'll just leave it all expanded like that. For the denominator, since those are complex conjugates, I could use FOIL and simplify it all out, but I know that I'm going to get 2 squared, which is 4, and then plus 3 squared, which is 9. Now, yes, if you just multiply it, you're going to get minus 9i squared, but the I squared will change that to a positive. So on the bottom there, I have 4 plus 9. So now let's simplify that a bit more. Looking at my numerator, the real parts, I have 10 right here, and then I have minus 9 here. So I ended up with 1. And then I have in the center, I have this negative 15i, I'm just kind of putting a scribble over it, minus 6i. When I combine those, I end up with negative 21i. But they're over they're both over this 4 plus 9, and 4 plus 9 is 13. And if they're both over it, they're each over it. I got the result of 1 over 13 minus 21 over 13i. Well, that number, with the original number I picked, 2 plus 3i, those are my answers. Z1 is the first number I picked, 2 plus 3i. And Z sub 2 is the result I got, 1 over 13 minus 21 over 13i. And I know we cannot see this as easily as we could see my example where the product was 20. But if you multiply, here's how you can know you did it right. Multiply the number you picked times your result, and you should get the result that they had told you would be your product. So that's some help for your homework. Forgive my humor when I was making out this one, but you want to see the next slide. It's the one that is set up to help you the most, honestly. And I almost feel bad giving this away to you as a teacher, but your graphing calculator can do a lot of this work. Let me bring up my graphing calculator so I can kind of click some of this stuff with you. So notice it says press mode and then select A plus BI. So mode is right here on your calculator. So mode. And then if you go down to see where this is real, we want to make this say A plus BI. So to get there, I'm going to use my arrow keys. And so I go down and then I go over and then hit enter. And now A plus BI is in dark. Okay, so that is going to bring you to mode. So now I'm going to quit this and go to a regular screen. And for just a minute, look at this. We have returned to the main screen. So we went to mode, we pressed A plus BI, then we hit enter, and then I hit second mode to go back to the main screen. Now, whenever you want to type in an I, you're going to hit second and then the decimal. So watch this sort of work. So if I needed to do 2 plus 3i, second decimal, let me type that in. And then I can go 4 minus 5, second decimal, brings an I. So now I've got two complex numbers I want to multiply, and I hit enter and it simplified it for me. So if you've watched to the end of this video, this is your little gift, okay? Set your calculator in A plus BI mode, and then to type your decimal, you can hit second decimal. So even if you needed to simplify something like I to the 75th, it equals negative I. So my friends, that's my gift to you for hanging on and watching that video. And now you can love your calculator, okay? Not sure you want to get a tattoo, but if you do, that's entirely up to you. All right, get in touch with me if you have any questions. That finishes this lesson.